Limits of accuracy. Measurements are never exact, but rather they are more precise. They are confined to a certain region, and many measurement instruments do not give the exact value of the quantity being measured, because many measuring instruments are only limited to a specific number of significant figures. Like say the vernier calipers, it cannot measure to the very highest degree of accuracy, or even the micrometer screw gauge. They are limited to a certain range. Now say a student measured the diameter of a soccer ball and found it as 19 centimeters, 6. Its true diameter will lie between a confined range, which is the lower bound and the upper bound. Now in this case, the measurement was to a 1 decimal place. Therefore, the accuracy is affected by the second decimal place. And in this case, we know the ranges of value that round up or round down to what? To 19,6. And that range of values is 19,55 and 19,65. Okay, you might say 19,65 may not round down to what? To 19,6. But actually, the upper bound would be 19,64999999, but which is approximated to 19,65. That's why we take the upper bound, which is what? 19,65, due to the fact that we have approximated to what? 19,65 from 19,64999. Therefore, the possible error of this measurement would be plus or minus 0,05 centimeters, which is given in the measured diameter. Now here I've got examples, an illustration showing you what it meant by the upper bound and the lower bound. In the middle you have the measured size, which is 19,6 centimeters, and on top we have the lower bound. And as you can see, I've tried to adjust the picture adheres into your mind, and you see what I'm trying to imply by the lower bound and the upper bound. The concept of approximations is illustrated by this variation of sizes. Now there's what we call the percentage error, which is given by the error over the measurement times the 100%. Now we want to calculate the percentage error of the diameter of the ball. Percentage error will be equal to our error. Our error found it as plus or minus 0.05 over the measurement. The measurement was 19,6 multiplied by 100%. And we get 0.255100204%. But in our question here, we want to round it down to the accurate significant figures. In our question, the highest number of significant figures we had was 3 in 19,6. Therefore, we can round it to two significant figures since it's still in the range which we want it to be. So we round it to two significant figures and we get 0.26. Now there's what we call absolute error. Absolute error is the approximate value subtract the true value, and this value is always positive, which means that no matter how you manipulate the equation, true value subtract the approximate value, you must always get a positive answer. Now the manufacturer of the ball gave the diameter is 19,9. This is now the true value. So the absolute error will be given by the true value might subtract measured value, or the measured value must subtract the true value, and we get 0.3. Now there's what we also call percentage error, which you can find through the absolute value and true value. Degree of accuracy. Many calculations involve measurements which are not accurate. As a result, this affects the degree of accuracy of the results which you get. The number of significant figures in the answer must not exceed the number of significant figures in the given data. Say in your given data, the highest significant figures you had in any of the numbers was 3. It means that you cannot have an answer which has 5 significant figures, as this will not adhere to the degree of accuracy in the question that you have. It is not advisable to round off intermediate values during calculations. Say you are working a continuous mathematical problem, but you find an answer which has maybe 8 decimal places, and you want to round it down. It is not advisable, as this will affect the accuracy of your answer. Calculate the circumference of a soccer ball with a radius of 19,9 centimeters. Circumference of the ball is given by pi multiplied by diameter. Now we know the value of pi is an irrational number, 3,94 what. And in our question, as you can see, we have 3 significant figures, 1, 9, and 9. These are the 3 significant figures that we have. Therefore, we must also do that for pi. Then we take the first three significant figures of pi. We have 3,14 and we multiply by 19,9. Then we get 19,486. Now, like I was saying above, we have three significant figures in our question from 19,9. Those are the three significant figures that we have for this particular question. Therefore, our answer must also have what? Three significant figures. Then we round off. Our third significant figure is what? Is 4. We look at 8. 8 rounds up. Therefore, 4 becomes 5. And our answer is what? 62,5. We're going to start with B. Length h is measured to one decimal place given as 9,5 centimeters. That is limit 9,5 centimeters. Now we want to find a range in which the values round up to what? To 9,5. We start with 4,5 being the lowest value or the lower bound, and these values range up to 9,5 49999. Okay, this is what the highest value we can get, but this value can be approximated to 9,55. It's 9,55. So now our range will be what? 9,45 less or equal to, since it's included in the range of our h. But our h will be less than what? 9,55. Since 9,55 is the highest possible value we can get, but we cannot get there. That's why we are putting the less than sign. Therefore, that is our range for the value of h.